This is lecture number 8. March 8th. Okay, so we're going to be talking about exponential expressions. In particular, we're going to start with a first definition. So a monomial, so the term monomial is a single term that has the following. 1, it has a number known as the coefficient. So this number that we're considering, we'll call it the coefficient. And the second thing is that it has a variable with a power, or also known as an exponent. An example, just an example of what that would look like would be something like this, 3x squared. So this 3 here is called the coefficient. The x here is my variable. And the 2 here is the power, or the exponent. And just having one of these guys is called a monomial. And then we'll talk more about binomials, trinomials, and in general, the word polynomials. Okay? Okay, and then let's recall what is an exponent. So exponents are numbers, and they're written as a superscript. A superscript just means that it's like on the right corner, upper right corner of a particular variable, such as x, right? So this 2 here is a superscript to x. So it's written as a superscript that denotes the number of times that the base is multiplied to itself. Example. Well, so when we say x to the 4th, right? So again, this variable here is like my base. So what's my base? It's x. What's my exponent? It's 4. So when I say x to the 4th, I really mean to say x, 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 x. I really mean to say that x is multiplied to itself 4 times. So we have x's appear 4 times in the product. Okay? And I think we should have an idea of that, right? Emil, what did you miss so far? Well, you missed the fact that exponential expressions we started with a monomial. And what a monomial is just a single term that has a coefficient and a variable. And we're discussing what exponents are. So x to the fourth is another way to say that x times x times x times x. So instead of writing x times x times x times x, I have a shorthand way of writing it using x raised to the fourth power. And this 4 is represented by a superscript. That's why we have this 4 above here. And that tells us the exponent. Okay, so that's something I feel like most of us have an idea of already. And now we're going to be concerned about simplifying. Sorry, I spelled this wrong. Simplifying exponential expressions. A lot of the things that you're learning in this class, particularly when it refers to algebra, you're really just learning a whole bunch of set of rules or a whole bunch of set of laws. So we're going to be learning certain laws of exponents. So example, what happens when I multiply? What happens when I multiply or multiplying exponential expressions? So an example, if I have x to the fourth times x cubed, well, what's the result? Well, x to the fourth, right? Yeah, you do add the exponent, but why is it that we add the exponent? Why? Well, what is x to the fourth? Isn't x to the fourth x times x times x times x? Isn't this x to the fourth? And then aren't you multiplying that with x times x times x, which is what? X cubed. So then aren't you really just saying that there's 7 x's? Right? So this whole thing here is really what? X to the 7th? So x to the 4th times x cubed is x to the 7th, which really meant to say that I'm adding the exponents. So this is what? X is really what? To the 7th is really 4 plus 3. So another example would be what? If I do y squared times y to the 6th, what do I know what's the result going to be? Y to the 8th. So then what's the rule or what's the law? What's the law when you multiply for multiplying exponential expressions with the same base? So if I have x raised to some power times x to the n raised to some other power, what's going to be the rule? The rule is what? X to the what? Keep the base the same and add the exponents would be what? M plus n. That's the rule. You can apply this rule to any scenario where the bases are exactly the same and you're multiplying them. So you're just adding the exponents. Right, mn, if you put them together without anything in between, it implies multiplication. And we'll see that a little bit later with the other rules. So this is the first rule that we can consider. So when you multiply the same bases, you add exponents. Okay, we've probably seen that before as well. All right. So that's the first of its kind. The second of its kind of the type of scenario that we will get when we have simplification of exponential expressions is we may have something that has, when we have raising an exponential expression to a power. So what happens now when I have something like this, x to the fourth, and this is raised to the third power? What is this going to happen here? What's going to happen here? Well, I can treat x to the fourth, I can treat this as a base, and look at the 3 first. What is it saying about the 3? It's saying that I'm multiplying x to the fourth to itself 3 times. That's what x to the fourth to the third power means. I'm taking x to the fourth and doing it 3 times. But then, based upon the previous rule, if I have the same base, what do I do with the exponents? Don't I add? So isn't this 4 plus 4 plus 4 instead? But what's 4 plus 4 plus 4? Can I write that in a shorthand way? Isn't 4 plus 4 plus 4 the same thing as saying 4 times 3? Isn't that multiplication? And isn't 4 and 3 exactly the numbers that I have here in the beginning? So then what's going to be the general rule? And what's 4 times 3? 12. So x to the fourth to the third power is really 12. So what's going to be the rule? Or let me do another one. What's z to the 8th squared? What is that going to result to? I can do the same exact thing, right? Z to the 8th times z to the 8th. Same bases, add the exponents. 8 plus 8. But what's 8 plus 8? 8 times 2. What's 8 times 2? Z to the 16th. So what's the rule that I have here? Or the law? When I have a base, I have an exponent, and I raise it to another exponent. What would be the rule? As seen by these examples here. And I think that's where you come in, David. It's x to the mn. You multiply the exponents. So it's going to be mn. Boom. So this is when you multiply exponents. So you add exponents when you multiply the same base. And when you multiply the exponents, you have this scenario where you have a power raised to a power. Right? I'm glad, David, that you've been waiting so long for this moment. Number 3. What happens when we divide? Dividing exponential expressions. Right. So you guys have seen this before, right? When you have, for example, x to the 7th power over x to the 5th power. But why is it that you divide? Why is it that you subtract, Emil? Do you know why?
Yeah, because it's pretty much like the opposite law, so to speak, as the one for when you're multiplying exponents. I guess an easy way to remember it, I guess.
Yeah, I guess you can think of it that way, right? You can say, oh, it's like the inverse, right? It's the opposite. So if I multiply, I add. If I divide, do the opposite, the inverse operation, then I would do the inverse operation accordingly. So that's another way to look at it. X to the 7th, though, the way I would show it is that x to the 7th, it's like saying I'm multiplying x to itself, right? How many times? 7 times. And I'm dividing that by x 5 times, right? And then what happens with the x's? I cancel them out. And what's left? Only 2 of them. But then the 2 can be represented as what? 7 minus 5. So the rule here is that when you have x to the m, over x to the n, the result is x to the m minus n. And we have a subtraction of subtract the exponents. And of course, it's the numerator minus the denominator. It's the numerator, the exponent in the numerator subtracted from the exponent in the denominator. So that's when you divide exponential expressions, you subtract the exponents. Okay, so far, hopefully so good. So number 4. Number 4 is raising an exponent. Raising an exponent by 0. So what happens, guys, when you have, for example, x to the 5th power raised to the 0th power? Well, what's the first rule I can do? I can apply 5 multiplied by 0 would give me what? 0, correct? Because 5 times 0 is 0. But what's x to the 0 power? Does anybody know that rule? If I raise it to the 0 power?
Yeah, it's 1.
It's 1. Very good. Does anybody know why? Jasmine, do you know why it's 1? So this usually happens, right? When you know something to be a fact, you know it's a fact. It's true. Yeah.
Isn't it because x always has a 1 next to it? So like if 1 to the power of 0 would just be like 1 time. But I don't even know. Wait, wouldn't it be just 1? Because x always has like a 1 next to it. I remember hearing that somewhere.
So that's true. There is a 1 in front of the x, right? In reality, there is a 1 multiplied by x to 0. But then how do you interpret x to the 0th power? Like, how do you interpret that? When you have 0 x's in the product, it becomes 1. I guess you can say because of the 1, but the more precise way is the following, right? I'm going to use the rules that we've already established to prove this new rule. So like for example, if you say x to the 0th power, right? Isn't this the same thing as saying x to the n minus n for whatever power it is? So isn't it true that if you take a power or an exponent and you subtract it to itself, don't you get 0? Correct? I'm not saying anything strange, right? N minus n would be 0. Now, if that's true, correct? If that's true, based upon the rule, what's the rule that we just established? We just established that if you subtract the exponents, it must have been a division of some sort, correct? So then if I do x to the n minus n, isn't it also true that it's x to the n divided by x to the n? Isn't this also true? So far, so good. And then what do we know about anything divided by itself? What does that result in? Yeah, if you have something divided by the same thing, what's the result? It's not itself. So for example, 3 divided by 3 is
1.
1. So that's why it's 1. That's why x to 0 equals 1. It's because of these intermediate steps that come from the rule. Now I said divide. If you divide anything by itself, you get 1. So that's the rule. So the rule is any base. If you raise it to the 0th power, you get 1. Now, I just want to say one thing about that, though. There's a warning. Actually, it's not any base. It's any base other than 0. So the exception to the rule is 0. Is if the base, is if the base equals 0. So for example, if you have 0 to the 0 power, this does not equal 1. If this really makes, there's no mathematical number that is associated with 0 raised to the 0 power. Anything else, though, to the 0 power will always be 1, but not 0. So that's the only thing you have to keep in mind. Okay, so 0 to the 0 power does not equal 1. It's more, we usually call this indeterminate form. So we say this is indeterminate, meaning that we can't really specify a specific number to this. This is indeterminate form, as they call it. Or undefined, some people say as well. Okay, but anything else works. Anything else, you can do 100 million to the 0 power is 1. Negative 0.00001 to the 0 power is equal to 1. Any other number works except for the base being 0. Okay, so that's the fourth scenario or rule that we have. So far we have, if you have the same base and you multiply, add the exponents. If you have a base raised to a power that's raised to another power, you multiply the exponents. If you have the same base and you have a division, you subtract the exponents. If you have any base raised to 0 power and the base is not 0, then the result will be 1. So far we're building up our toolbox of exponential functions. Now we're getting to the more interesting thing that people like or dislike strongly, and they're negative exponents. So negative exponents is what makes this, I guess, a little bit more interesting. I'll start with an example here, okay? So what is x cubed over x to the 7th? So what happens when I have something like this? What's the rule? Same base, division. What do I have to do? I have to subtract. What do I subtract? Is it 7 minus 3 or 3 minus 7?
3 minus 7, and then you get x to the negative 4th power.
Very good. Very good. Now, that's one way, right? That's one way to interpret this. What's another way to interpret it? X cubed over x to the 7th. I can rewrite this as what? X times x times x divided by x times x times x times x times x times x times x, right? What happens with the x's? Cancel, cancel, cancel. This is a 1 in front in the top. I'm left with 1 in the numerator, and what's in the denominator? How many x's are left? 4. So I'm going to write what? X to the 4th. Now, what's the connection here? Aren't these expressions exactly the same thing? In one manner, I got x to the negative 4th being the result. In the other manner, I got that the result was 1 over x to the 4th. So then what's the conclusion? X to the negative 4th has to equal what? If this equals this, and it's exactly the same thing here, this equals this, then the result is x to the negative 4th is exactly 1 over x to the 4th. So then what's the rule, guys? The rule is that if I have x to the negative nth power, what's going to be the result? It's 1 over x to the n. That's the rule. If I have a negative exponent, make it positive by doing what? Placing it in the numerator. So I'm going to write that out. So if an exponential expression has negative exponents, move the exponents, no, move the expression to the denominator to make exponents negative exponents into positive ones. That's the rule. So if I have an x to the negative 100, for example, I will make it positive by putting 1 over x to the positive 100. Okay? Now, in the same vein, though, what if I have 1 over x to the negative 4? Now, the difference here is that the negative exponent is not in the numerator, it's in the denominator. Now, how do we take care of this? Well, I'm going to treat the 1 normally. And again, what is x to the negative 4? Didn't I just show what x to the negative 4 is? Isn't it 1 over x to the 4th? So then you're like, wait, that looks complicated because it's 1 divided by another fraction. But then how do you divide fractions again? Remember? We keep, change, and we flip. We keep the first, we change division to multiplication, and then we flip the exponent. So what's the result? 1 over x to the negative 4 is really x to the 4th power. So then what's my rule for this? My rule is that if I have a exponent in the denominator that's negative, how do I make it positive? Put it in the numerator. And that's the key rule, guys. That's going to be the key rule. If I have a negative exponent in the numerator, make it positive, put it in the denominator. If I have a negative exponent in the denominator, make it positive, move it to the numerator. That's it. That's the rule.
Professor, I actually have a question.
Yes.
So for the first rule where you converted x to the negative n power into 1 over x to the positive n power, do you have to do that conversion, so to speak, or can you just leave it at x to the negative n?
So we're going to be exactly making every exponential expression with positive exponents.
Okay.
Yeah. So that's the reason why we were covering this rule, is because this is going to be a very essential rule when they ask you to when you're being asked to simplify exponential expressions. Part of the simplification process is to make all the negative exponents positive. So sure, you're right. You can just leave it like this. That's right, technically, but we want to make these all positive exponents. So that's
So
going to be our goal. And then
well,
eventually,
yeah,
Mhm.
yeah. Yeah, you
Yeah.
were saying?
No, I'm saying that, and then eventually we're going to have negative exponents in the denominator, and we want to make those positive as well. So the goal is to make, or the step is, we're going to make this negative exponent positive by placing it in the numerator. And you'll see that as we do more of these problems. Right now, we're just setting up all our rules. We're just making sure all of our rules are established and clearly defined so we can apply them.
Yes, sir. All right.
So this is when this is if an exponential expression has negative exponents in denominator, move expression to the numerator to make positive exponents, to make negative exponents into positive ones. Right? So that's how you deal with negative exponents. And now we can see all of this. Hopefully we can see all of these things in action with the first set of examples here. All right. So I want to simplify. I want to give just examples of simplifying. Simplify the following. So if I have an example here where we have negative 2a squared b cubed multiplied by negative 4ab squared. So now I want to know what the result of multiplying these two monomials are. So what I could do is I want to rearrange product with like terms. What do I mean by this? Well, one thing about multiplication, right? All of these numbers here are being multiplied. Whenever you don't see, when you see two variables or numbers, or variable with numbers, if you see them bunched up together or they're just next to one another, the implication is that there's a multiplication that's occurring between them. And whenever we have multiplication, as you can see, all of these numbers here, all of these terms are being multiplied to one another. Because they're being multiplied to one another, multiplication has a property called commutative. It's a commutative property. The commutative property means that I can rearrange the order of multiplication without changing the result. Because of that property, I'm able to do this. I'm able to say, hey, take negative 2 and multiply it to negative 4. And something called the associative property with the parentheses, I can say, hey, let's do multiplication of negative 2 and negative 4 first. Then I can rearrange what? All the terms that have an a in them. So a squared with a, I can make all the a's, just multiply them together. And then lastly, multiply all the b's together. So you see what I did there? I just rearranged the product so that I can associate all the like terms to one another. And now multiplication becomes very straightforward. Negative 2 times negative 4 is positive 8. A squared times a to the first power, whenever you don't see any number, there's a 1 there. What do you do with the exponents? You was I too fast? A squared times a to the first power is same base. What do you do with the exponents? You
A cubed.
add. So it's a cubed. And then b cubed times b squared will be what?
B to the 5th power.
Thank you. And so therefore, the result is a cubed b to the 5th power. So is this clear? Any questions upon this particular example? Straightforward, I presume. Okay. So now what happens when I do 3a b squared cubed? Now, one way to interpret this is I have this 3 here, correct? I got the 3 outside, which means that I'm really doing this. 3ab squared multiplied. 3ab squared multiplied. 3ab squared. That's really what's happening, right? I'm multiplying to itself 3 times. And then I'm going to do the exact same thing that I just did. I'm going to rearrange it so all the 3's, the coefficients are together being multiplied. All the a's are together being multiplied, and all the b squareds are associated with one another being multiplied. But what do you notice? What is 3 times 3 times 3? Isn't this 3 cubed? And what is a times a times a? Isn't this a cubed? And what's b squared times b squared times b squared? Isn't this b squared cubed? And what's 3 cubed? 27. a cubed. And what's b squared parentheses cubed? What do you do when you have a power raised to a power?
You multiply.
You multiply the powers, so you get b to the 6. So this is my result. And based upon this result, I can get another rule. Let's see what rule. Yeah, I can do another rule. What's the rule? The rule is that if I have x to the m times y to the n, and I raise it to another power called p, I can rewrite this as x to the mp multiplied by y to the np. This is just an extension of the rule of a power raised to a power. Now, the only difference is that in the base, I have a product of two different variables being raised to the same power. If I do have that, then I can raise individually each of these to the same power p. And this is what happens here. When I had this here, right? I had this cube here. But what's the result here that I figured out? I figured out, hey, I'm really just taking 3 and cubing it. I'm really just taking a and cubing that. And I'm really just taking b squared and cubing that, which results in b to the 6. So this rule is just to help me go from here to here instead of doing these 2 steps. But I showed these 2 steps to show you why I get this rule. Okay? So we'll see more of that in the next example. If I got negative 2a squared b to the squared power multiplied by negative 3ab squared squared. So it's going to be a whole bunch of exponents from now on. A whole bunch. Again, it's all about the rules. So based upon the rule that I just established, how do I take care of this expression here? Remember what I'm going to do? I'm going to take this term negative 2a squared and take b, take them individually and square them all. So what's that going to look like? It's going to look like negative 2 squared times a squared squared times b squared multiplied by what? What's the next guy? Negative 3 squared, a squared, b squared squared. So I'm going to have negative 3 squared times a squared times b squared squared. So then what's negative 2 squared? 4. What's a squared squared? Yeah, we'll get to the answer, Emil. So what is a squared squared?
A to the 4th power.
Good. It's a to the 4th power. B squared is just b squared. What's negative 3 parentheses squared? 9. A squared is just a squared, and b to the squared squared? B to the 4th. Then what do? We associate everything that's of like kind, right? 4 times 9, that's something you can pair up. A to the 4th times a squared, you can pair up. B squared times b to the 4th, you can pair up. What's 4 times 9? 36. What's a to the 4th times a to the 6th? A to the 2nd power is a to the 6th because you multiply. You multiply the bases, so you add the exponents. And the same thing goes for b to the 6th. So yes, Emil, you are correct. Very good. Any questions about this? No questions, no problem. This is the next one. So here we have 3x to the negative 2 times y to the 6th power times negative 4x to the 5th y to the negative 8th power. So what am I going to do? I'm going to associate everything that is of like kind here, right? The 3 and the negative 4, I'm going to multiply them together. I'm going to take x to the negative 2, multiply by x to the 5th power, multiply that together. I'm going to multiply y to the 6th, multiply by y to the negative 8, multiply that together. Now what's 3 times negative 4? Obviously, Negative 12. What's x to the negative 2 times x to the 5th power? Well, remember what you do with the exponents? You add them. So negative 2 plus 5 is positive 3. And then y to the 6 times y to the negative 8. The exponents here also are added. 6 minus 8 is y to the negative 2. Now, I've done the multiplication, but what's the only issue here? The issue here is that I have a negative exponent. How do we take care of negative exponents? I want to make them positive. And how would I do that here?
In this case, Professor, would you just do 3 plus negative 2 or no?
Well, you have to go back to the rule. What's the rule? The rule only applies to same base.
Right.
The moment there are different bases, you can't even touch it. You can't do anything with the two.
So it's negative 12x cubed times 1 over y squared.
Okay, so good. So this is negative 12x cubed, right? Times 1 over y squared, correct? Do you see that? This becomes, this here, you apply the rule that we established here. If you have a negative exponent, put it 1 over that exponent, right? But we're not done. Really, there's a 1 over this, right? There's really a 1 over this. And I just want to make sure this is clear, that when you really put this over the denominator, you literally can just do this, 12x cubed over y squared. Because when you multiply exponents, when you multiply fractions, how do you multiply? Don't you multiply them across? So this y squared, this y negative 2, can really just be placed underneath and make it positive. So it's y squared. So this is the simplified version. Okay. Any questions about that? So no questions about that. We'll just continue on with the next example. What if I get this? Simplify the following. I got 6m squared n cubed all over 8m to the 7th m squared raised to the negative 3. My goodness gracious. What in the world do we do? You'll start to see that as these examples get more complicated, as these expressions get more complicated, you'll start to see that there's no one correct way of doing so. Like there's not just gonna be one way of simplifying. There might be more than one way. You might have to apply some people might apply one rule first and the other. So it's okay if the steps that you think of doing are different from the ones I present, because there might be more than one way of approaching this. For example, in this example here, there's more than one way. Right. So Yim brings up a good point. Do you first do the things in the parentheses first? That's normally what you would do, right? That's normally what PEMDAS tells us to do. PEMDAS will say do parentheses then exponents. So there's nothing wrong with doing the parentheses first. It's just that we could eventually, soon enough, we're going to talk about a new kind of rule with the negative exponent associated with fractions, and you'll see that you can actually apply the negative exponent first. But for now, we'll do the inside the parentheses first. So we're going to take care of the parentheses first. So forget about the negative 3 for now, and just worry about the inside. Now, how do we take care of the inside? Well, the thing is, we can separate this as 6/8 multiplied by m squared over m to the 7th multiplied by n cubed over n squared. Do you see that? I can simplify it. I can separate it as a product of 3 fractions. And why did I separate it? Is because I can simplify this, and I can simplify this individually. 6 over 8 really is what? 3/4. Then what's m squared divided by m to the 7th?
M to the negative 5.
Right. M to the negative 5. And then what's n cubed times n, divided by n squared? It's just n, correct? So this is the simplification of the inside. Now, you can continue with the inside, making the negative exponent positive and all that. Or you can apply the rule that we just applied. You see how there's many avenues to the right answer? We can apply this rule here. If I have a product of expressions and all of them are being raised to the same exponent, I can raise each of them individually to that exponent. So let's do that. I'll take 3/4, raise that to the negative third power. I'll take m to the negative 5, raise that to the negative third power. I'm going to take n and raise that to the negative third power. And I'm going to take care of each of them individually. Okay, now how do I take care of 3 to the 4th, 3 over 4 to the negative third power? So let's take care of this one first. 3/4 to the negative third power. How do I take care of that? Well, this has a negative exponent. How do I make it positive? Put 1 over it, and I get 3/4 cubed, don't I? Isn't the first thing we do? Okay. And then what is 3 over 4 cubed? How do I interpret 3 over 4 to the third power? Isn't this just 3 to the 4th? 3 over 4 times 3 over 4 times 3 over 4. And when you multiply fractions, don't you multiply them across? So 3 times 3 times 3 is what? Isn't this 3 cubed? And isn't 4 times 4 times 4 4 cubed? Isn't this 1 divided by 27 over 64? And isn't 1 over 27 over 24 the same thing as saying 1 multiplied by 64 over 27 by the reciprocal, which is 64 over 27?
Yes.
Good. So I took care of the first one. Now, what's the second one? The second one here. M to the negative 5th power raised to the negative 3rd power. What do I do? What rule do I apply? I have to multiply. Negative 5 times negative 3 is positive
15.
15. And then the last term is n to the negative 3rd power. Make it positive by doing what? 1 over?
1 over n to the 3rd.
N cubed. Good. And so I'm pretty much done. Of course, I'm not going to leave it this way because I can write this as a single fraction. And that's always what I want to try to do. When I simplify, I try to simplify with the positive exponents. That's first. And the second thing is I want to put them all under the same fraction if possible. And I can write that as 64m to the 15th power all over 27n cubed. So therefore, this is the result. So then there's a little bit more rules to the game now. There's more rules. One extra rule that I want to show you is that if you have, and hold on, I think stopped. Okay, sorry guys. I think it's not connecting. I'll fix that real quick. Just give me 1 second. Technology. Okay, so that's up. And then I'll share my screen. Bam. All right, we're back. Okay, so this is my rule, right? So what's my rule that I can apply is that if I have a fraction like a over b, and I have this to the negative nth power, I can rewrite this as a over b to the nth power, which gives me a to the, sorry, I flipped this. This is b over a to the nth power, which is really b to the n over a to the n. And this rule is found, how do I know about this rule? Is because I applied it here. I found that this guy here, if you notice, is the same thing as this guy here. Or if you see here, this goes to this example here. And if you flip this, this becomes, if you flip this guy here, this becomes 4 cubed over 3 cubed, which is exactly 4 over 27. So that's another rule of exponents that we should know. Okay, and this is, we're just building right now. Next one, a squared over b to the fourth. If I square this, well, this is something similar to what we've just done, right? A squared over b to the fourth squared is a squared over b to the fourth multiplied by a squared over b to the fourth, correct? That's what it means to square. And then I can multiply the exponents as, I mean, the fractions as a squared times a squared over b to the fourth times b to the fourth, which is the same thing as saying a squared squared over b to the 4 squared. And if you do a squared squared, you multiply the exponents. B to the 4 squared, you multiply the exponents. So what's the rule here? What's the rule that I can make here? Well, if I have a base called x and raise it to some power, I should write it in yellow. If I have x to the mth power divided by y to the mth power, and I raise it to the p power, this can be rewritten as x to the mp over y to the np. That's another rule here that I can use from now on. So if I have a fraction, and within that fraction I have powers, and that fraction is being raised to some other power, I can individually multiply the powers to the exponents. So that's the rule. Okay. Alrighty, and now I'm gonna have something else similar to this, but now I'm raising this to the negative 4th power. Now, if you notice, this is very much the same thing as this rule, isn't it? I got x, 3rd power. I got y, 2nd power. That's my m and my n, respectively. And then my p power is negative 4. According to the rule that I just established, I can write this as x to the 3 multiplied by negative 4 over y squared to negative 4. But what's 3 times negative 4? Negative 12. 2 times negative 4? Negative 8. So it's x to the negative 12 over y to the negative 8. But of course, we don't want negative exponents. So what do we do to make those negative exponents positive? What do we do?
You would do something maybe like 1 over x to the positive 12th power times y to the 8th or something.
Yeah, so if you want to be very technical, you can make each of these 1 over x to the 12, and this would be 1 over y to the 8th. But didn't I say that in one of those first rules that we talked about negative exponents, if you want to make this negative exponent in the numerator positive, what do? Put it in the denominator. If you want to make the negative exponent in the denominator positive, what do? Put it in the numerator. So Maria, that's a good idea. Let's just switch them. So this is y to the 8th over x to the 12th. and that's it. Done.
Professor, I have a question.
Yes.
Why'd you just switch them? I don't understand that.
Okay. So if you don't understand that, let's do it slowly. X to the negative 12, right? What is x to the negative 12? I can write this as what? 1 over x to the 12, correct? Made it positive?
Yes.
Okay. And then this division symbol is still there. And then I'll do what? 1 over y to the 8th, right? I made both these negative exponents positive by the rule that we have, right? What's the rule that we have? The rule we have is that you have a negative exponent, make it positive by putting 1 over that number, right? So I'm applying the rule. I've applied them. Of course, this looks kind of weird to just leave it that way. How do we take care of this? Well, we can write this as 1 over x to the 12 multiplied by the reciprocal, y8 over 1. Isn't this true? Keep, change, flip.
Yes.
But then when you multiply fractions, what do? You multiply across. So isn't this y to the 8th over x to the 12th?
Yes. Yes.
So that's why.
Yeah,
And so
I got it.
eventually,
Yeah, I got it. Thank you.
yeah, eventually though, these steps, intermediate steps, right? We don't have to do them anymore because we already know that this is the result. And so therefore we come up with these rules, right? Our rule is going to be the following. Now, if we have x to the m over y to the n, and this is a negative exponent, what's going to be the rule? The rule is going to be, hey, switch the order of the fraction, just switch them, reciprocal, take the reciprocal, and multiply individually. That's going to be the rule. And then the reason why you switch them is because of the rule. So whenever you have an exponent in the negative, in the denominator that's negative, make it positive, move it in the numerator. If you have a negative exponent in the numerator, make it positive, move it to the denominator. That's going to be now the general norm. That's
Professor,
the norm.
so could you actually switch them first and multiply if you
You can
wanted
do
to?
that. Yeah, you can do that
Oh,
too.
okay.
You can take this negative exponent, right? So see, that's very good. Now you start to see that we can do this now. We can do this. X cubed over y squared to the negative 4, right? I can make the negative exponent positive. Didn't we set that up? Yeah. This rule here, negative exponent, right? I can make this negative exponent positive by doing what? Switching a over b to b over a. So I can switch this. Y squared over x cubed. And I got positive exponent by the rule. And then I just continue on, right? I continue on y squared times 4 over x cubed times 4. And I get y to the 8th over x to the 12th, which is exactly what I just got. As I said, these rules start to kind of like seem to appear as the other ones. So you have to be clear as to what rules you're applying. And you also have to be aware that there's more than one way of getting the right answer. There's not just going to be one single way. There's going to be many different directions you can go depending upon the steps that you apply. As long as your steps are correct and consistent, then it doesn't matter what you do first. It doesn't matter if I do this direction here, as you can tell, I do everything correctly, I get the right answer. Or I can apply another rule first, and I get still the same correct answer. And you only get better with this with practice and practice. That's all. Lots of practice. Okay. U negative 9 to the negative 9, u to the negative 6, v to the 4th, all over 6u. So this is going to be a little crazy, okay? Because we're going to have a lot of negative exponents. But we need this so we can have a very good understanding of what to do when we're given these kind of problems. Okay? So what do we do here? Or what do you think we should do? Or what could we do? What can be done? What rules can be applied? Again, there's no correct answer as to which one should we do first. As long as it is a correct answer, that's what matters. So anybody have an idea as to how to proceed with this, how to approach this one? So what do we notice? We have a fraction. The numerator is being, that whole numerator is being raised to negative exponent. And that whole denominator is being raised to negative exponent. And within those parentheses, you have negative exponents. So there's many ways you can approach this. I have like 3 different ways you can approach this. But does anybody have a particular suggestion? Distribute the exponent first. So yeah, that's probably the most common way. You can say, hey, we can take n in the numerator, raise it to -1. Take u to the -6, raise it to the -1. That's one of the rules, right? And take v to the 4th, raise it to the -1. I think that's probably the easiest one to do. And then the next one will be what? 6 to the -2. U to the -3 to the -2. And then v to the -2 to the -2. So I took all the exponents that's associated with the parentheses and took everything inside the parentheses and raised it to that same negative exponent. Okay? Now take this a little step by step. I'm just gonna leave the 9 to -1 for now. And look at the next one. U to the -6 to the -1. I can multiply the exponents and I get u to the +6. V to the 4th to the -1. I multiply the 4 with the -1 and I get v to the -4. I'm gonna leave the 6 and -2 for now. U to the -3rd to the -2 power, multiply -3 with -2 and I get +6. And I take v to the -2 to the -2 and I get v to the -4. Or positive, pardon me. Negative times negative is positive. Okay. Now, what can we do now?
Since we're dividing, we subtract exponents and we can see that the u to the 6 is common, so maybe we could cancel those out.
Of course, u to the 6 over u to the 6 is uno, 1. You cancel. So the u to the 6 goes away. Now you said, hey, you got v to -4 over v to the +4. Whenever you divide same base, you subtract the exponents. So -4 minus 4 becomes what? V to the -8. So that's the result of that. Okay, and then how do we take care of the 9 to the -1 power over 6 to the -2 power? How do we take care of that fraction there? Don't you have negative exponents here? Negative exponents here? How do I make them positive? If it's in the numerator, what do I do? Put it in the denominator. If it's in the denominator, what do? Numerator. So I can rewrite this as what? 9 to the 1st power and 6 to the 2nd power. It's that easy. And then what's 6 squared? 36. What's 9 to the 1st? 9. And what's 36 over 9? 4. And do I want negative exponents? No. So if I have this v to -8, what do I do to make that -8 exponent positive? What do I have to do? Make it to the denominator? Yeah, put it in the denominator. So it's 4 over v to the 8th, and that's my final answer. I can't do anything else. So you see, these are the steps, guys. This is not the only way, but this is a way. To go from this whole thing here, looks very complicated, to something very simple. One single fraction. So any questions about this? Okay, so if no other questions, then let's see if we can do two more really quickly. If I got 20 r to the negative 2 t to the negative 5 over negative 16 r to the negative 3 t, s to the negative 2. So how do I simplify this? This is less work than the previous one.
You would just do 20 divided by negative 16, and then you do negative 2 minus negative 3.
Which is what?
I'm sorry, what?
Which is what?
What do you mean?
What is negative 2 minus negative 3?
Negative 1. 1.
Positive 1.
Yeah,
So I
1.
got r to the first power. Does everybody see that? So I'm just going to slow down a little bit. Negative 2 minus negative 3. Okay, and then what do you do with the rest? So we took care of this fraction, and then what happens with these guys? What do you do with these guys?
You leave them the same way because there's no common base.
That's fine. Yeah, but what happens with the exponents? They're negative, right? I want to make them positive. So then what do I do to make them positive?
So you switch.
I switch. So this becomes what? S squared, and this becomes what? T to the 5th. And then I can simplify 20 over 16, can I? What simplifies 20 over 16? I can divide both by what? 4. This becomes 4. This becomes 5. Negative 2. What is negative 2 minus negative 3? Isn't this negative 2 plus 3, which equals positive 1? So don't I get in the numerator, don't I get 5 r to the first power times s squared? And in the denominator, I'm left with what? Negative 4 t to the 5th power. And I'm done. So this one wasn't too many steps. Now the last one we're going to deal with is probably like the boss level, I would say, of these kind of simplifications of exponential expressions. So this is basically almost everything but the kitchen sink. So this is 9a b to the negative 2 all over 8a to the negative 2b. This is raised to the negative 2 power multiplied by 3a negative 2b over 2a squared b to the negative 2 raised to the third power. So we want to go from this, from a division, a product of two fractions with negative and positive exponents, to a single fraction. So we have to do things sequentially or in an organized fashion, step by step. So if you want, we can take each of these fractions individually and simplify them first and then put them together at the end. That might be helpful. So let's look at this first, and then let's look at this one here, and then we'll put them together. Okay, so let's look at number 1 first. And can we simplify number 1? So we got 9a to the b to the negative 2 all over 8a to the negative 2b to the negative 2. So what should we do first? Or what could we do first?
Wait,
Yes?
maybe we could distribute the exponents in each first, like in our numerator and the denominator.
Yeah, we can do that, but I think it might be better if we simplify the inside first. Let's do that first, and then we apply a negative. Because if you notice, the 9 and the 8, that just stays there, right? But what about the a's? You see the a's here? They got a's here. So what's a over a to the negative 2? So I got a over a to the negative 2, and I got b to the negative 2 over b. This whole thing is negative 2. What's a divided by a to the negative 2? What does this become? So remember, we have a to the first
Because
power. Mm-hmm.
it becomes a to the second over a.
Okay. So please be careful with that. Don't get confused with saying that, oh, if I want to make this positive, I switch the entire fraction. No. You only switch the entire fraction when both of them are negative.
So you would do a over a to the second over 1 times a.
Oh, yeah, you want to, yes, a over 1 over a squared like this.
Yeah.
Yeah, but eventually what I'm trying to get you guys to see is that if I have a negative exponent in the denominator, how do I make it positive? Just put it up. That's it. So this is really going to be this. Look, this is really going to be a multiplied by a squared. And it becomes what? A cubed. But maybe you don't believe me, right? Maybe you're like, no, that doesn't make sense. And then you say, okay, what if I apply the rule? What's the rule when you do this? Don't you subtract the exponents? So don't you get a 1 minus negative 2? But what's 1 minus negative 2? Isn't this a 1 plus 2, which is a cubed? Don't I get the same thing? Do you see why it works? So if I have a negative exponent, just make it positive by putting it above. Look at this. If I have a negative exponent in the numerator, make it positive by doing what? Putting it in the denominator. That's it. It's as simple as that. So you do 1 over b times b squared to the negative 2. And I get what? 1 over b cubed to the negative 2. And now I can make this into a single fraction. This is 9a cubed over 8b cubed. And this whole thing is being raised to the negative 2 power. Now, how do I take care of this negative exponent? Negative exponent, I have a fraction. What do I do to make it positive? I have to flip the fraction. So this becomes 8b cubed over 9a cubed squared, positive, right? You see that? That's one of the rules. Then I can take everything inside and multiply it by square it. 8 squared b cubed squared over 9 squared a cubed squared. What's 8 squared? 64. What's b cubed squared? B to the 6. 9 squared? 81. A cubed squared is 8 to the 6. So I simplified the first huge fraction there. Now I'll do the same exact thing for the second one. Same exact thing. So let me just take this, copy it. So then what does this become here? Again, we hopefully we start to develop a little bit of speed and intuition as to what to do. I got a negative exponent. I got a negative exponent. How do I make this negative exponent positive? Put it in the denominator. How do I make this negative exponent positive? Put it in the numerator. So then what do I get? I get b times b squared over what? A squared times a squared. And all of this is being cubed. Do you see that? Do you see that I can do that? I have negative exponent in the numerator, make it positive, put it in the denominator. I have a negative exponent in the denominator, make it positive, move it to the numerator. That's all I'm doing. I'm doing moves. I'm moving them around. And then what do I get? I get 3b cubed. What do I get here? I get 2a to the 4th because I'm combining them, right? Same base. Same base, add the exponents. And now this whole thing is being to the 3rd power. Take everything, cube it. B cubed, cubed. 2 cubed. A to the 4th cubed. What's 3 cubed? 27. What's b cubed cubed? B to the 9th. What's 2 cubed? 8. What's a to the 4th cubed? A to the 12th. Done. So far, I simplified those fractions. But of course, I'm not done yet. Why not? Because I'm multiplying them. I'm multiplying 1 and 2. So the final thing is I'm multiplying 1. So I'm multiplying 1 multiplied by 2, which will give me what? 64b to the 6 over 81a to the 6 multiplied by 27 over 8 multiplied by b to the 9th over a to the 12th. And of course, I can now associate, right? If I multiply across, I can multiply like this. 64 multiplied by 27 over 81 multiplied by 8. And I can combine b to the 6 times b to the 9th over a to the 6 times a to the 12th. And then what's the result? I get b to the 15th power, and I get a to the 18th power, correct? And now what happens with these numbers here? Do you notice something? The 8 goes into 64 8 times. The 27 goes into 81 how many times? 3 times? So then the result is going to be what? 8 over 3? And this is my final answer. Let me just write this again. It's going to be 8 b to the 15th over 3 a to the 18th. I know it's kind of crazy at the end. It's a little crazy, but all these rules are converging at once. And so it requires a lot of practice to get used to the rules, get used to how to apply them, when to apply them. But with practice, anything is possible.